Hello, we are going to continue with section 8.2, which is right over here. So the last video, you kind of just learned about hypothesis testing, but this one is specifically about one proportion z-test. And basically we do that test if somebody makes a claim about a population proportion, like we were talking about the coronavirus earlier. Somebody could say the death rate in the US is 10%, and you could say no way. You take a sample and get 2%, and then you would reject their 10%. Okay, so let's go ahead and fill these guys in. Sample size is always n. The population proportion is p. The sample proportion is p with a little caret over it, and the significance level is alpha. Like I said in last lesson, this is 5 steps. So now we're going to be running through the whole entire test. Okay, so let's go look at a problem. Before I was toggling back and forth. Now I'm just going to keep StatCrunch open on the right, so it won't be so bad on your eyes. Okay, so whenever I'm reading the question, I'm really not looking, at first I'm not looking what's going on in the sample. I'm looking, what are they saying about the population? So the headline read, more than half of Americans say taxes are too high. So that's a clue, that's direction. More or more than. So they're saying more than half of Americans. It was based on a simple random sample. So they saw the sample and they says, oh, it's more than half. Is this accurate? So since it's not dealing with like means, it's dealing with the count, it's going to be a p. So that's p is greater than 0.5. And if you watch the last video, you could see that if it's anything with a greater, less than, or not equal to, it's going to go in your alternative. And your null is always going to be, hey, it is 0.5. Okay, so in this case, it's a z-stat. They kind of tell you it's a z-stat. That just means it's a z-score. So anyways, what happened is they think it's 0.5. They take a sample, and it's 534 over 1026, which I'm just going to calculate that real quick. I have a more fancy calculator now. So 534 divided by 1026. What am I doing? I need to get to that screen. 5. So based on this sample percentage, which is 52%, they think that it's that in all Americans it's more than 50%. So that 52% stays somewhere over here. The test statistic that we're about to find is basically how many z-scores this 0.52 is away from this 0.5. And then the p-value is going to be that shade right there, because it's a right-tailed test. That's going to be your p-value. So we could do this using StatCrunch, doing a z-stat. So z-stat, one sample. We don't have the data. The data would be yes, no, yes. We don't have that. We have a summary. Okay, so I'm in something wrong. I apologize. This should be prop stat. I mean, it is a z-score. This shouldn't say stat right there. That should just be z equals. Hey, that's when you know something went wrong, is when you get this somewhere and they start asking for means and you're like, wait a second. I don't have a mean. I have a count. Okay, so proportions, one sample. We have summary. This looks a little better. The number of successes. The successes are how many said that, which is 534. Observations is 1026. And all I have to do, they have this defaulted at 0.5. I just have to change that into a greater. Now once I hit this compute, it's not going to let me bring that over, but that's okay. My z-score, this is basically all I need, is a 1.311. The p-value is 0.095. The alpha is right there, 0.05. Now since 0.095 is greater than 0.05, what that basically means is this result is not out of the ordinary if this null is actually 50%. So if the truth is really 50%, their sample result was not that out of the ordinary. So we're not going to reject it. So we're going to fail to reject H null. Okay, now your conclusion always has to be about this person. So since we did not reject this, we're kind of taking this as being true, even though we really can't, officially say this is true, because it could be 49%, it could be 51%. We're not going to officially say this is true, but we don't have evidence that it's greater than 50. So we do not have evidence that, try to write a little neater, more than half of Americans say taxes are too high. So go figure. Okay, so that's all 5 steps. Let's go to the next one. Okay, so with this new one, there's a scanner, and his study of stored checkout scanners, there was 4,234 items were checked for price and accuracy. 20 were found to be overcharges, and 1,214 were not overcharging. So then they throw this claim that with the scanners, 1% are overcharges. That's their claim. So their claim is P is equal to 0.01. So since the claim was unequal, we're going to put claim equals 0.01. Now the alternative, you're looking for direction. Like, do we think there's more than 1% of overcharges, less than 1%? They never give that, so this is a not equal to. That part could be a little tricky, so you make sure you really, really want to practice. And proportions are always prop stat on StatCrunch, whether it's an interval or a hypothesis test, any type of problem with proportions or stuff, data where they're doing counts. Remember, they're scanning an item, and then the question is, when it gets scanned, it's either a yes or a no. The next one is either a yes or a no. That's what sends you to proportions, because they're going to count up the number of yeses. If it was an average problem, then, which we're about to do later, then that would be a z-stat or a t-stat. Okay, so let's go ahead and run the test. Get rid of that. So stat. The successes in this case are how many were overcharged, which was 20. Actually, before that, let me figure out what that percentage is. So just so I have an idea. So they ran 1,234, and 20 of them were overcharges. So let's see what that is in comparison to 1%. That's 1.6%. So they got 1.6%. So the question that we're really answering is that 1.6% out of the ordinary? Or is that 1.6% just, that could have just happened naturally? Okay, back to this. There was 20 successes. If you look over here, there's 20 that were overcharges, and the rest were okay. Remember, the observations is total of scanned. Now we have to change this hypothesis to what the null says, which is 0.01. We could keep this as a not equal because nowhere in here says, hey, they think the scanner's doing this more often, it's doing less often. They're just trying to check to see if 1% seems reasonable. Okay, and that's it. So we got our, they call it Z-stat, but it's really a Z-score. It's a little misleading when you're picking tests. And one of the tests is a Z-stat, which would make you think you'd want to do a Z-stat. So you'd have to be careful of that. So this is 2.19. Let's go to our p-value, 0.0284. Okay, our alpha. Okay, your significance levels are alpha. That's what we use to reject the null. Okay, so the p-value 0.0284. Yep, that's less than 0.05. So we are going to, what they're saying is this result, this 20 out of 1, 2, 3, 4 is something that's unusual if the null is true. This result would not be expected if it was really 1%, so we're going to reject the 1%. Which just means we're going to reject the null. So therefore, we found evidence remember, I'm writing about this guy now. We found evidence. Let's see the question. Test the claim that the scanner overcharges are different than 1%. We found evidence that the scanners overcharges was, I'll just say, different than 1%. A lot of people want to say greater here, but you can't say greater. I know that this result is greater, but that's not what we're really testing. We're testing it, we're trying to say if this is wrong or not. Okay, now we're off to 8.3. Basically, all the proportion tests sort of are like that. Okay, so what's good about here, or what we have to be good at, is whether we hit the Z-stat button or the T-stat button to run our test. Z-stats if sigmas are known, and it's T-stat if S is known. Okay, so let's read this question. The mean IQ score for stats is known, but distributed greater than 134. They have 12. Mean is 137, and S is equal to 15. So I'm always trying to figure out, hey, what was the data collected? In this case, the data was IQ scores. Well, you could get an average with IQ scores. Okay, so that's what makes it a mean test and not a proportion test. They're not counting anything. They're actually getting the IQ scores from the professors. So once I know the data is quantitative, they could get a standard deviation. So I'm looking at this guy right here. That tells me it's going to be a t-test or a t-stat. Okay, so what's the claim? The claim is that greater, right here, greater than 134, and it's a mu. And anytime you have a greater than here, it's going to show up in your alternative, which is H1. So that means our null is 134. So basically we're saying it's 134. Prove to me that it's not. That's 134. Prove to me it's not. Well, they took a sample of 12, which is a pretty small sample size, and they got an average of 137. And then they're like, okay, well, does this seem just ask yourself, does this seem out of the ordinary? Or does this seem pretty likely? To pick 12 people and get an average of 137. That's the question we're asking. So we need to find the t-score. So we're going to run the t-test. T-stats, one sample. Okay, we don't have the data. We don't have the actual scores. We have the summary. Sample mean was 137. Sample standard deviation is 15. Sample size 12. We need to change this to 134. And this is a right tail test, so it's a greater than. And compute. So we ended up with a t-stat of 0.69. Right here, there's your t-stat. Three. I know it says round to 4 decimals, but 3 is fine. The p-value is 0.2514. Our alpha, so significance level 0.05. That's what we use to reject the null. So we do 0.25. We compare the p-value to the alpha. If that's greater, we're going to fail to reject. If the p is high, the null will fly. So basically they're saying that this 137 was not far enough ahead of the 134 to say that it's greater than 134. Remember, the 134 is about all professors. The 137 is about the 12. So we're trying to use the results from 12 to say all professors are greater than 134. In this case, the results from the 12 were not enough to say that the true average of all 134 is greater than that. Sorry, the true average of all professors is greater than 134. So in this case, we have insufficient evidence that the true mean of all stat professors is greater than 134. And that's that one. Okay, so this looks like a long one, so if you want to I'll go ahead and pause my video and then read it. Okay, so I've read the question, and basically it's about Sarah, who has 44 hens, and she averages about 6, well, her hens average 6 eggs per week, and she wants to compare that to the Golden Comet's egg production, which this is the egg production for all of theirs. So she wants to see if her hens are higher. See that keyword right there, higher. So her claim is that her true average is higher than the Golden Comet's, which is 5.7. Okay, remember this 6 is actually an X bar, because this 6 eggs per week actually comes from her 44 eggs. So that's that's not the population, that's a sample of her eggs, which is 6 eggs per week. And she is different, she's feeding them these, all this other stuff, and probably trying to get more eggs. So if this is a greater than, your alternative will be a greater, and then your null will be an equals. Okay, so now we have the decision. Is this a t-test or t-stat or a z-stat? And that decision always comes from, are we using S or are we using sigma? So we scan through to here, we have a sigma right there, 1.3. So we need to be doing that. I just did that backwards. I'm sorry. Sorry about that. Okay, so just forget everything I just said. It's going to be a z-stat if it's sigma, and a t-stat if it's s. Now s would have came from the SD of these 44 eggs. And this sigma is the standard deviation of all these golden comments. So we need to be doing a z-stat. That would look like this, z equals. Okay, so let's do the test. One sample, summary. Okay, so her sample mean was 6. The standard deviation was 1.3. The sample size was 44. Okay, now this has to change to the golden comments, which was 5.7. And hers was 6, and she's trying to say, hey, is hers more than the golden comments? So 6, 1.3, 4.4, and voila, there we go. We got z-score of 1.53. And a p-value of 0.0629. I did scan through this. I didn't see an alpha, so we could just fix our alpha at 0.05. That's fine. You could pick anywhere from 1% to 10% for your alpha, but we just stick with that. So her 6 was not far enough above the 5.7 to claim that hers were better. So we're going to fail to reject the null. So this number is bigger than that number. So we're not going to reject this. Now remember, Sarah wants her average to be bigger than this, but her 6 just wasn't enough. So we have insufficient or no evidence that the true mean egg production for Sarah's hens is above 5.7. Okay, and for the last question, I've already went ahead and read this question. So go ahead and pause it and read it, and then come back. Okay, so a simple random of these pages from a dictionary are normally distributed. So they're really measuring the number of words on like each page. And they think that there's more than 70,000 words. Well, if there's 70,000 words, and they think there's more, but let's say there was 70,000 and you did 1459, that's how many pages there were. If you do this calculation, that would tell you how many words there were per page. That's kind of it's not, you don't really need to know that because it's going to come out to be 48, hopefully. So 70,000 divided by 1459, that should be 48. So it's pretty close to 48. Okay, so if it was really 70,000 words in the whole book and there was this many pages, there would be really close to 48 pages per book. Well, they think there's more than 70,000. So if every page had more than 48, then the average would be bigger than 48. So our claim is that the true average is greater than 48. Okay, so once you get the true average greater than 48, your alternative will be greater than 48. So your null will be that it is 48. Okay, so if every page has 48 in the whole book, then you would get 70,000 and they would be wrong. So they took this simple random sample and then 1, 2, 3, 4, 5, 6, 7. They got 10 pages. So let's just scan through these 10 pages and see. 65, that's way above. A little bit below, above. So it seems to me that this book probably has more than 70,000 pages based on the 10 that I'm seeing. That's what a hypothesis test is. Okay, based on this random sample, we're going to make a decision about the whole entire book of all these pages based off what happened in 10 pages. Because you picked 10 pages randomly. If it was 48, these should all be closer to 48. Okay, so let's decide what test to use. So just like last time, we have a Z-stat and a T-stat. I won't mess it up this time. Z-stats are for sigma, T-stats are for S. So scan the problem and look for this sigma thing. The sigma is the true standard deviation of all 1,459 pages. And we do not see that. So what they're going to do is they're going to calculate the S from these 10 for us. Okay, which we won't see. You just have to know what button to push. So now what we have to do is we have to enter this data into a list. And you're not going to believe how fast I'm going to do this. So, okay, did anybody beat me? Okay. So let's go ahead and finish running this test. We said it was going to be a T-stat, so stat, T-stat, stat. One sample. Now in this case, I just put the data in, so we're going to go data. To say, okay, data, that's the one there, and let's match my null up to my null, which is 48 per page. And then if they think it's more than 70,000, if there was more than 70,000, there'd be more than 48 defined words per page. So click on that, and we are ready to run the test. It's just give us a T and a p-value. There you go. So we got a T of 3.3, which you could think about these T's like the Z's when we did a long time ago when we were looking for something that was out of the ordinary. It was outside of 2 standard deviations. That'd be like this one right here. That's the p-value, which I just got from here. Now our alpha is 10% here. There's your other video. No, that's pre-calculus's video. I don't know what that is. Okay, so their alpha is that. So you always want to compare your p-value to your alpha. And in this case, it's less than. So if the p is low, the null must go. So basically what we're saying is if there were 48 defined words on every page, and we pick 10, the chances of getting the average of these 10 would be very, very out of the ordinary. So we're going to go ahead and reject the H null. So we're rejecting this. So there we have sufficient evidence that the book contains more than 48 words per page, 48 defined words per page, or more than 70K. Okay, so that's like a little example of each. If I have time, I may post a few more videos, but maybe not, because I'm going to go ahead and do the homework. So anyways, thanks for watching. I appreciate it, and stay safe out there.